It's visible, right? Now for what we need to do basically is we need to set up a layer 2 topology for this. Okay. So that's R3, R4, R1, R2. Okay, R1, R2, R3, R4. Let this be R5 here. That's router 5. Okay, and we have one IPS. Okay. Okay. Now let's see the configs. Okay. Let me open this because I don't want to switch again and again. Okay. Now, very first, let's start with this router. Where is router 1 here?
G01.
Right. So,
It is.
now let's start with this router. So now router 1 is here and G01 is VLAN 10. Okay, so let's check where is our router 1 G01 is connected. So here is the physical topology. Router 1 G01 is connected on switch 4 port 1. So I go to switch 4, interface F1/0/1, switch port host, switch port, VLAN what? It's visible, right? Font. Okay. Next, same router 1, but another interface which is 00. Now this is connected on switch 2 port 1. Check this. 00 is connected on switch 2 port 1. So I go to switch 2. Okay, interface F01, switch port host, switch port, access VLAN. What's the VLAN there? 20. Okay. Exit.
Sir,
Yes.
why interface you put F1/01?
On switch 4.
For
Yeah, here this one.
yeah.
Because this is same. The interface name is like that only. Switch 4. Show IP interface. Do you see the interface names? It's F1/0/1. Okay, next device in the line is
WLC or access point.
okay, fine, let's do this. AP, this is on switch 1 port 6. Okay, WLC ports are on switch 6. So what I need to do here is these ports I have to trunk. Wherever WLC port 1 and 2 are connected, those should be trunk. And these are connected on switch 6 port. Exactly. So on switch 6, interface range G1/0/ what happened? Reconnect. Connect again.
Connect it again. TeamViewer. Go to TeamViewer. Hang हो जाता है. Reset. Restart.
Pull that cable. Put it in your laptop then.
Which cable?
Cable from the PC.
Cable from PC.
Access point is on switch 1. Done. बानू यहाँ पे चेक करना, स्विच 1 पे वो लूज तो नहीं है सभी ब्लिंक हो रहा है.
सर एक चीज़ और, वो जो WLC होता है उसका कॉन्फ़िगरेशन हमें कुछ वहाँ पे लैब जो रहेगी CCIE लैब उसमें कुछ करना पड़ेगा पूरा WLC का कॉन्फ़िगरेशन.
डिपेंड्स.
वो देते हैं नहीं देते हैं तब.
डिपेंड्स. नहीं ये हो गया उसका क्या. यहाँ पे कनेक्टेड है ना, आप है ना यहाँ पे, वहाँ पे भी आप है. Okay. Next is Next is M00, the management interface of IPS. Okay, let's see where is this connected. IPS. It's connected on switch 1 port 12, and you would see it here. Okay, this is your IPS. This is the management interface, and it goes and connects to switch 1 port 12. So this should go to which VLAN? 20. So we go ahead and put this in VLAN 20. That's switch 1, right? So here interface F012, switch port host, switch port. Done? Okay. Next, next is firewall. Okay, this segment here, firewall E01. Okay, and this belongs to VLAN 30. Okay, so let's go ahead and do this. Firewall 1 E00. Now where is ASA1 E00 connected? This is ASA1 E00 is on switch 2 port 8. So switch 2 is here and port 8. goes to what? VLAN.
30.
Okay. Then what else?
We don't want to SS7 activate.
Easy. Yeah, those we can. Yeah, that's already there. That's already in VLAN 150. Both these machines, okay, your Active Directory and your ACS server, both are on that VM machine, which is already in VLAN 150. So it should be in VLAN 150. Both these machines are already in VLAN 150. Okay. Now, what else do we need? Okay, E02 of the same firewall. This should go to VLAN 2. Okay, so let's go and do this. Switch to, that was 01, right? So firewall 01 is connected here. Angelo, could you please keep your phone aside? 01 here is connected to port 9. Switch to port 9. So this should go to which VLAN?
VLAN 2.
Port F09, switch port, host, switch port, access, VLAN 2. Then 02 of the firewall should go to which VLAN? No, that was 02 only. Yeah, 02 is in VLAN 2, 01 is in VLAN 100. Okay, so this should be VLAN 100 and interface VLAN. What is port 11? Switch to port 11. Switch to port 11 is port 2 of firewall 1. Port 11 of switch 2, we have configured this in VLAN 2. Now, how do you find out what is connected on port 11? Switch to port 11, what is connected? Port 2 of
G00.
that's it. Okay, so you check it here. Port 2 of ASA1 is in VLAN 2. Similarly, port 1 is in VLAN. Okay, we need to configure port 3. Port 3 is in VLAN
After the configuration of firewall, we will do it.
5. So let's go and check where is port 3 connected.
This is not switch, this is IPS.
Angelo, port 3.
Oh, there are two VLANs.
Where are two VLANs? Where do you see two VLANs?
There are VLANs 5, VLANs 5.
Dude, you need to concentrate on this.
Yesterday I told you that it is easy.
Router 4 is in VLAN 55. You are looking at firewall. You are looking at firewall interface E03 here. Okay, so this is in VLAN 5. Now check where is this interface connected. Firewall 1 interface 03. Where is this connected? Port 12 of. What do you need to do? This should go to VLAN
5.
interface F012 switch port host switch port VLAN. Firewall is done. The next is what? What is it? Router 3, I guess. Okay.
This is in VLAN 22.
Next, router 3. This is in VLAN 22. And router 4. This is in VLAN 55. Look at the interfaces G00. Okay, so let's knock out R3 first and then we'll go to R4. So let's see where is R300 connected. Scroll up. R300 is on switch 3 port 1. So switch 3 port 1 goes to
22.
interface F01 switch port host, switch port access, VLAN, and then interface F02. Here R4 is connected. Done. Switch 4 port 1 is R3. Switch 3, yeah, switch 3 port 2 is R400. So this is in VLAN 55, this is in VLAN root. Okay. IPS, okay, IPS we have already done.
Only management put here.
Only management put here.
Other ports are remaining.
This is R3, R4. We have R5 as well. Where is R5? Let's check. Did we put R2? No, we haven't. Okay, let's first do R2. R2 G00 is in, and R2 G01 is in VLAN. Okay, so let's do this. R2 is here, and R200 is in VLAN. So first of all, R2 is connected on switch 2 port 2. Access VLAN. Another interface is 01. This is connected on switch 4 port 2. VLAN. Finally we have R500, which is connected on switch 3 port 3. So interface F03, VLAN, what?
192.
Done. Anything else remaining? R5 done.
IPS sensing interface.
Yeah, that we have to do it later. Anything else?
The server B1 RDR. Which kind of server is this?
Yeah.
Server B1 RDR. In VLAN.
Oh.
VLAN interface.
Done. Let's go ahead and do this. Where is the console? Okay, on this port actually access point is connected. Let me shut it down for time being. Okay, we'll come back and we'll make it up. So this is on switch 1. Copy. Okay, this is switch 1, config T, and that's the configuration. Port 6 is, this is for access point, and this is for IPS management, port 12. Done. Next, switch 2. Port 1 is R1, port 2 is R2, port 8 and port 9 are firewall, port 11 and port 12 are again firewall. So switch 3, switch 4, port 1, this is R1, this is R2, copy and paste. Finally this is switch 6, huh?
Why switch 6?
WLC, no?
WLC.
Show interface. We are configuring which one? Port 2 and 4, right? What is on 2? What is on 4? Now check trunk and let's check WLC.
WLC ID password is? Admin name? Password is?
Capital WLC @2500. Fine.
Password WLC @2500.
Okay, help me out. R1G00.
R1
10.0.25 20.1.
but here they are low.
Interface 01.
10.0.10.1.
10.0.10.1.
Then
Router 2.
R2. Where is R2? Here.
172.16.10.
R200 is what? 172.16.0.10. 10 is firewall. Okay. And what is 01? 110, 1. That's 01. Okay, fine. Then R3. What is R3? 192, 168, 3. Okay. Firewall. We'll do it. On R2 and R1 we'll do it. R3 done. Okay. This side you have R4, 192, 168, 40.4, right? Okay. R4. and firewall is the git.
40.10.
Done. R5. 1 dot.
20.5.
Done.
Sir,
AS.
this one you have from
Where?
Cloud 50.
the
110,
So when you
1.20.
press on R4, it's G00 or F0?
F00. Then you can go to the router and check. There's not a, these names you can go to the router and check. No problem.
You must check before to put it.
I remember. You guys have to cross check it.
But I don't know, that's why.
Now for exam you guys need to check all the ports.
For check which command?
If wrong, it will not
Yeah,
come.
it's okay.
If wrong, it will not come.
Yeah,
Keep change it. Okay.
Done. We have a firewall in between on ASA1. This would be interface E0. Wait, let me check.
No, it's not easy.
This is to remove everything, okay? But be careful, don't
Yeah.
just simply execute this.
Sir, when you make a clear configuration, it means
It removes everything.
everything.
Yeah. Show interface IP brief. It's G00. So interface G00. Name if inside IP address
Change
10.0 dot what? 30.10. Then 1 is outside. Name if was IP.
172.16.0.10.
Then 02.
DMZ? No, inside.
What's the name there?
Sir, wait. Sir,
Yes.
wait.
Good.
Neki branch, what is that? What is this command?
Its name.
But
Ah,
I don't understand.
what?
If it is class C,
What is about inside?
What 03? DMZ.
It is about DMZ. What's that? Look like that. Listen, security. Online. Don't be saying that thing. I'm back.
Done. Done. Inshallah.
Yeah, she told me inside it is R1.
What happened inside?
No, because when you put the branch R here, I say that it should be inside. It should be inside. Okay? See that? Yeah.
You want?
Anything.
Okay.
Doesn't matter. You just need a unique name. It should not match. I cannot do this. I cannot do this because this is already taken by one interface.
You can't do some DLG like DLG.
Any name which is already used, you cannot give here. Okay. But you can use any unique name. It's the name and the security value what matters. Okay, not just the name. Fine. So here, this interface is unique with the help of this unique name and this value. So it is different from this interface because it has a different name and two interfaces can have same value, but they cannot have same.
Sir, we can move from this branch router to DMZ.
Inline
From branch router
Huh?
R3 to
Huh?
R4.
Huh?
We can ping.
No, not by default.
Because the security level
It is same. Exactly. You cannot communicate between two interfaces with same security level. Done. Now here you see a layer 3 switch as well. Okay. Which one do you use? Let's use switch 6 only. Very first. Then interface VLAN. First of all, interface VLAN 20. Where is interface VLAN 20? Dot. Okay. IP address. Done. Then another one. Isn't? Okay. Shit. And finally dot. No, we haven't given. Done. Now what we have done basically is, for this layer 3 switch the gateway is firewall. For ACS and for your DNS, gateway is .10. Again the switch, we need a gateway for R1, so the R1's gateway should be here, 10.0.20.2. so let's go back to R1. Where is R1? R1. Okay, here is R1, and we add a route IP. That's the default gateway. Done. Then okay, fine, perfect. R3 we have given a gateway towards firewall. R4 we have given a gateway towards firewall. Let's check firewall. Firewall should have a gateway towards R2. So let's scroll down, check the firewall. Firewall doesn't have any route, so let's add it. Route. And the next stop is R2.
16.0.2.
Fine. Okay. That's it. R2, I think we have added the route, I don't know. R2 need to have a default gateway towards internet. Let's go and check this. Where is R2? Okay, here is R2. There is no route here. Let me add it. IP route towards exactly. Done. Do you think routing is complete or we need more? Complete over?
No.
I put all the arrows. Tell me, is it complete?
What?
Routing. Do you have complete routing, end-to-end routing, or you need IPS not in routing? Let's say I'm on firewall here. And let's say I'm on firewall here and I want to communicate with this network. Do you think I would be able to communicate?
No.
Right now my firewall doesn't have any route. My firewall is aware of this network, aware of this network, and aware of this and this. That's it. He has no idea about this network, or this network. Those are third network for him, for the firewall. So we need what? Okay, so what do? Let's run some dynamic routing protocol and provide the connectivity. Okay, so what I'm going to do is I'm going to run dynamic routing protocol, let's say EIGRP, but I would be running this only on the internal segment. So till here this is my inside. This is my private network, private network, private network, and private network. So I'll be running on all of this. Okay, I am not going to run on this segment. Nothing. Okay, so let's do this.
Close to R1.
Okay, you need this diagram. Where is it? Now help me out. This is R1. Don't worry about the gateway, that's too.
Router EIGRP.
Yeah, on R1, how many networks? I say router,
EIGRP. Network. No auto-sync. Network 10.0, 10.0. 10.0, 20.0.
that's it. Huh? Okay, next.
R3 or R2.
R2, okay. R2,
172.16.0.0.
not on the outside, only on the inside segment, G00. Nothing on the.
R1.
Done?
Inside.
Okay. Next,
R3.
on R3.
192.168.30.0.
R3 we don't need R3.
It is directly connected to VLANs.
Because R3 there are no more networks. R3 is simple. Huh? Okay.
R4 is directly connected with
Yeah.
AS. You don't need to.
Then R5 we don't need, or we need on firewall. First of all, inside 10.0, 30.0.
10.0.
Uh,
172.16.0.0.
okay, so let's say if you have to reach 192.168.30, your gateway gives it to the router gives it to the firewall knows it, he gives it to firewall. Okay, fine, done. Okay, and last device where you need to do the routing is on your switch. Okay, so do it here, router. Wait. Yeah. 10
10.0.30.0.
0.30, 10.0.20, and
10.11.0.
on this switch we need to run it on 1, 2, 10, 0, 30, 0, 10, 0, 20, 0, and 10, 11, 11, 0. Done. Okay.
This is your I think this is your
Six on. No, it's close. 192, 168, 10, 100.
Fine.
Firewall.
This is router 1. R2, right? That's on R2. That's on R3. R4. This is R5, the outside segment of the network. ASA1. Inside, outside, branch router, and that's the router.
So both sides, so switch and
Huh?
firewall. EIGRP.
Hmm?
So firewall and switch. Router. And router.
No, we have done a lot of places. So route learned from the inside network. Check the topology. That's the firewall, okay? So from firewall perspective, on the inside segment, you need to know how many networks. Right now it's showing you 3 networks. You need to know 10, 11, 11, 0. Perfect, here. You need to do 10, 0, 30, 0, which is here. Perfect. And 10, 0, 20, 0, which is here. There's one more network.
Let's start 1066.
Okay. So even we should get this one. Why this one is not reflecting? Okay, it already has a gateway. It's working fine. Okay. Okay, let's do this. Ping. So I'm on R1. Okay. Let me ping the gateway very first. 10.0.20 dot. That's the switch. Ping 10.11.11. Then ping 10.0.30 dot 10. That's the firewall. Okay. Further I can do telnet 172.16.0 dot 2.
Because telnet is by default inspected by ASA panel.
Let's go to firewall. Do one thing. Go to SA1. Show running. See map. Now from here we'll not be able to go here, or we'll not be able to go here as well, for the reason we haven't configured these segments in between. So there's right now there's no connectivity between R3 and firewall, R4 and the firewall. Okay, but we are able to reach till. Okay. Let's do one more thing. Okay, this ping is all the way from here. Done. Okay, so right now there is no connectivity issue. Okay. What I'm not going to do is I'm not configuring this part. This part is not for you guys. Okay, but let's say there is a PC here, we can use and simulate this one, no problem. Okay, now what next? Turn on these machines, both. Okay, now let's begin with very first initializing.
IPS with management office.
Okay.
So R2 we are given routes of inside network. EIGRP. Since inside network we are given. On
Okay.
R2 EIGRP.
Yeah.
Just inside network.
Exactly. Done. Now see, as we already have routing, okay, and we are already in VLAN. We are already in VLAN 150. Let's say we'll use one of the PC here. Okay, and from here all the way from this VLAN through this switch we'll go and access IPS through, because we have routing.
सर सर्वर का पासवर्ड
No, just enable it. That's it. That's more than enough for me. It's up. That's it. So if it is up, we can test it by ping 10, 11, 11, and I don't know.
अरे ऐसे बंद कर दो.
ऑन किया
check its adapter, VM adapter. Okay, no problem. We'll get it because we have reachability. Once it's up, we'll get it.
Yeah, yeah.
Hmm?
Login.
No. Check its VM adapter. Is it bridged?
This, yeah.
Huh? It will come in some time. Okay. Now let's get back to the device. Okay, we had initialized IPS in the beginning of the lab. Let's get back to IPS. Okay, now okay, if your IPS is factory default state, then you would see something like this.
If
Your device is in factory default state, which means you have not configured anything when you bring it from the factory.
From beginning.
Yeah.
Like this.
You will get this name, sensor. Okay, what you need to do is log in.
Then what's password? Password?
Capital CISC.
Yes.
Oh, one.
Cisco
Done.
01.
What we need to do is we need to set up this device. Okay.
Yes.
Now for setup, okay. No. Basically, what you need is you need to use this command, which is, and this command takes you to a configuration dialog where you get different values.
system setup is there.
Okay, and you need to key in the values, and finally your device is up. All right. You need to use this keyword to set up the device. You need to say setup. Okay. And when you hit enter, it will give you different values. You need to put the values there. There are some default values as well. So you put the values. Finally, it will set up. You save it, reset, done. Now, for look here, this is more important. Okay. If you do this command on the IPS, this would take a time to show up the output. Okay. Apart from this, you have another way of doing this, which is go to global configuration mode. Now you guys don't know anything of this device. Okay. Though there are very little controls. Check this one. You don't have too many commands like you have on router. Very limited commands.
Not 20.
Yeah, most of the thing you would be doing under. So you have to say configuration. That's what you have, no? Angelo, you are so surprised. Privilege mode, to go from privilege to global configuration mode. Config T, right? Huh? Okay. Now, how many commands do you have here? Check. Not so many. Okay. Now here, most of the work you are going to do under this keyword. Okay. Most of the work you are going to do under this keyword. Service. Again, do a question mark. Under service, we have these many options. Again, these are not too much. Very little controls here. Now again, you don't know anything what to do under AAA, what happens under analysis engine, what happens under host, what happens under interface. But you can find out how. Let's say I want to know how to do host configuration. Let's say I don't know. You say service. Exactly. now under this what to do, I don't know. But what you can do is say show settings. Look for this output. Now this is your help. Okay, this is for your help. You can use this for your help. This is not for your help, but you can use this for your help. Okay. Now I don't know how to configure IP address for the device, but by looking at this output I can understand how. I have to say, first of all I have to say network setting, which means here I have to type network. Under network setting there will be a keyword where I have to give IP address in this format, followed by mask in this format. Then I have to give a comma, and then I have to give my gateway. This is the current value and this is the default value, which means if I want to access IPS right now at this moment without doing anything, what I need to do is I need to set up my PC on this subnet. I can set up my IPS 192.168.1.1 maybe, and I can launch the same like WSC. Okay. If you want to configure the device name, keyword is, the default name is sensor, as you can see it here, but you can change it. So here you see whatever you see, this is default, this is present config. So if you give some other name, maybe IPS 123, so here it would be something different, and so on. Okay, any place you want to see this, that's what you need to do. Service. Okay, I want to say how to configure, let's say, web server for this. I don't know, but I can use. Okay, I need to say first of all I need to say show web server, and under this directly I need to say port, and I need to give some port. Default is 443, which means I can only do HTTPS, no HTTP. Done. Okay, anything else? Service, maybe AAA or maybe network access, let's say show use go on using the keywords. Under keywords you will get the config. Get this? Okay, anytime anything you want to see, I would say use this rather than using show configuration. It takes time, it consumes time. So try to make a habit of doing this, so you would be familiar with this then. But if you stick to that old way show configuration, then first of all it's going to take your time, and you would never come to know what command is under what, how to configure, nothing. So if you do this way, at least you will get idea, okay, this type of configs are done under this control, and so on. Okay, but while initializing you could do this. You have to say setup, enter. Okay, now at any point you can enter a question mark for the help. Okay, you can use Control C to abort. Maybe you may make a mistake, you want to restart with this configuration dialog, just say Control C and again say setup. Okay, and whatever values are in the bracket are your default settings. So right now the default name is, you can change it, maybe
CCNP IPS Security SITCS. CCNP IPS.
okay, CCNP. That's the default IP address for, as per, where the hell is this? As per our topology, the IP address has to be 10.0.20.5. You guys can read this, right? So let's go and set up. IP address is 10.0.20.5/24. What's the gateway? For IPS, the gateway is .2. Done? Okay. Now you have an ACL on the sensor, which is to allow the host or allow a particular subnet to connect in. Right now there is nothing. Why?
By default it's no.
Okay. Huh?
By default it's no.
Yeah, there is nothing, which means no one can connect. Now see, if you happen to enter this type of situation, like I wanted to modify ACL but I did not by mistake, so what you need to do is Control C. You are back. You can restart the setup by saying okay. So CCNP dash IPS, IP address is 10.0.20.5/24, 10.0.20.2. Yes, no entries right now, but I am going to modify this. I'm going to permit 10.11.11.0 subnet. That's it. Let's say you have a host, maybe administrator on some remote site, and you want to give him access. Okay, let's say that this host is in is R5. This host is router 5. So what's router 5 IP? 110.120 dot. This is a host slash for host for subnet slash 2016 whatever, but for host slash 32. So which means from outside only R5 can access the IPS, which is on inside. Done. Okay, that's it. At this moment here, don't write anything. Don't write anything, just hit. You will come back to the configuration dialog. Done. You don't have to say anything here. No. You can leave it. Let it be no problem. Done. So far we have done just this much configuration. Where have we done this? Service host. Under that you can write down keyword network setting. Under that you can say host IP, host name, telnet. How are we going to give access? Let's allow this. So for that you can go to, anyway that's the default value, so just put enter. Telnets right now you can, by default you can access your IPS on port 443, which means you need to just say HTTPS 10.0.20.5. that's it. But you can change this. You can change this, maybe fine. Finally, for which we have to say, anyway that's the, so just hit okay. We have configured, it doesn't take effect. What you need to do is just exit out. Done. Do you see the change?
Yeah. Host name is changed.
Okay. Again relog in.
Cisco.
I told you don't use, stay away from this command basically. Okay. If you want to see, you can, if
Service.
so that was the default setting before, and now whatever I have done, it's here. That was the default name,
This is
default present. By default there was no ACL, present, and so on. Okay. Not setup, you can come and do it here, because you have got the idea, right? So if you want to make some changes, let's say you want to permit a particular host, say service host network setting access list, and do it here. But this you'll get familiar with this if you do it this way. Otherwise you have no idea which where to get which command. That's it. Okay, so easy way is
Show settings.
always while practicing do this way, so you will understand, you will have idea that okay, this part of configuration is under this subconfig. Otherwise it's a bit difficult. Okay, done. Now let's access this device. Okay, let me try it. So very first what I would like to do is 10.0.20.5. Yep, I have access. So now what I need to do is HTTPS 10.0.20.5 and we need to access it on 8. Over here say now some of you might face Java problem, and I don't know whether even I might end up in this same. Okay, no, I have the right version. I mean, it's not a problem. Okay, key in the same value, the same credentials what you're using for your CLI. So Cisco, capital C. It's faster. Now for this reason I didn't want to put it on projector because controls are very small. I can't help it. Done. Okay, so now oh god. Now this is your device dashboard basically. Okay, you can see the information right here on this box. Okay, basically you can see this, that the host name whatever we have specified, CCNP IPS, that's the version. Okay, IP address, device type model 4240. Okay,
So it gives us the type of device.
yeah, it's here.
This device.
It's here. It's here.
Yeah, I know. I see that. Not I want to know if it is about this device, right?
We are accessing these devices, about this device.
Okay.
Okay. There are total 4 what?
Sensing.
Okay. That's your CPU memory and load status here, and you guys can see this,
All of that down.
that only your
Minus.
interfaces, remaining 4 sensing interfaces are fine, perfect. This is about your licensing for the lab environment. This really doesn't matter. Okay, this is required for the real time. Okay, for the lab environment this is not required. Okay, now
Why do you send the red arrow in that sensor help?
where
In sensor help, right side, right?
here
The arrow is a red part. Right, because
yeah, you have different values here. Okay, and each one has a different meaning.
Because your signature is not updated, so if you are in critical condition.
Okay, your yellow has a different meaning, red has a different meaning. Okay, so here red means critical. Okay, because we are not updating in this. Okay, from a long time, this is from 2030. Fine. Now, yeah,
Normal.
That was security name.
You are in green.
And
That's
it's
normal.
also,
there's no load on this. There's nothing configured. The device is completely blank. Okay, now what we need?
sensing interfaces.
Configuration part. Okay, now what I need basically is, let's say from R5, if we do something, maybe we try to send to test this basically. Let's say what I want is, I want to know whether my this interface of the sensor 00 is able to sense this or not. Okay, you guys know that the actual packet should
Go this way.
come to the inside network. Simultaneously, a copy should reach
IPS.
that IPS can give it to the sensor database and we can check it. Basically, that's what I want to happen, for which
First we have to
we need to use some method wherein we can get this data, right?
switch using span.
So how to do this? First of all, we need to do what? We need to identify where is
0, 0.
right. Okay, so this should go to VLAN. Then we need to check where is R5. From this interface we need to take the packet and give a copy to this interface, wherever IPS sensing interface is connected. So first let's go and identify where these are connected. So this is G00 interface of IPS. Let's check the physical topology.
Switch 5, 1 VLAN.
So 00 is connected on switch 5 port 01, and as you guys know, we need to copy it from
R5.
exactly. R5 is somewhere else. They both are not on same switch.
So you need to do
R5.
Switch 3, port 3.
Switch 3, port 3.
So basically from switch 3 port 3, this port, I need to copy the data and take it to switch 5
5.
port 1. What to use, span or RSPAN?
R span, because there are two different switches.
Because they are on the two different switches. And you know, do you understand this? See, this is switch 3. Okay, from outside the packet will be coming from R5. So this port here is port switch 3 and switch 5 are trunk. Okay, and on switch 5 port F10/1 you have G00 interface of yesterday's configuration. I want this to be the source, but for destination what do I need?
What is the question?
This is my source port. I want to copy it from here.
Okay.
What should be my destination?
First we have to create a VLAN, which is known as
My destination should be
R span.
RSPAN VLAN.
Yeah, R span VLAN. 999, whatever line.
So I put it in RSPAN VLAN. It will reach switch 5. On switch 5 my source will be
R span.
exactly.
And the destination should be F10.
Source will be RSPAN VLAN and my destination would be port F101, which is okay. So let's go and do this. I go to I go to switch 1 very first. Why?
To create R span.
Because switch 1 is VTP
This is a VTP server 1. So first we make it into VTP
5
transparent.
3. These are in VTP.
Kind of line. Show VTP status.
So if I do something on switch 1, it gets replicated to switch 3, switch 5 plus other switches as also. But that VLAN I need only on switch 3 and switch 4. Assume to switch 1, configure T, VLAN,
R span VLAN. Normal VLAN.
okay.
remote span.
Done. Show okay, let me remove this 999. Fine. That same VLAN 911 which is a remote span VLAN, I should be able to get this on where? Exactly. Show VLAN and on switch as well. Okay, so switch 5 is on the another terminal. This is on switch 3 and this is on fine. Okay, switch 3 I say wait no show interface. Basically I want to copy it from here. Okay, so monitor these are the options what I was talking about.
Monitor session 1 doesn't
Monitor done. Switch 5 I say monitor why 1/0/1 exactly because on port 1/0/1 IPS 00 is connected, and for this configuration what do we need? We need IPS 00 interface. We want to get the data here, isn't right? So this is done. How to test? Now for testing we need to do the configuration part on IPS. And one more thing what I need to do is, which I did not do, switch port host, switch port access VLAN 192. There's VLAN 192 here. Yeah, it's in VLAN 192. Fine. Hello. Yes. Hello. Okay. What we need to do next here is, okay, this G00 is not up. Okay. For testing purpose, let's do one thing. We go to router 5 and we try to ping R2. So if I am from R5, if I try to ping here, which basically means what?
the
Copy is sent.
to IPS.
Actual packet reaches R2, but the copy is sent to IPS as well. Okay, we want to confirm this. If this is working fine, then remaining part is done under IPS. That's the configuration part of signatures and extra stuff. But basically, until and unless you are not getting any packet, it's not worth it. So first we need to make sure we get the packet, copy of the packet. Okay, so right now what I do is I go to router 5 very first. I say ping. It's working. We don't get any updates there for the reason the interface 00 what you see on the screen is down. So to make it up, what we need to do? Go to
That interface.
configuration. Okay, wait, I'll write down these things, but because so what we have done now is, let's review back on
On switch 1.
on switch 1. I say VLAN 911. Okay, remote span. Then on switch 3, what do I do is I say not interface, monitor session 1. On switch 5,
Vice versa.
VLAN what? VLAN 192, and then fine.
On source, both 911 and both.
No. Now on IPS, what you need to do is basically you need to go to under configuration, go to
Interfaces.
under that go to not sensor setup, go to interfaces. Under interfaces, so go to interfaces. Under interfaces again go to interfaces. Okay, and under this, okay, select and say, and then
Apply.
fine. So where to go? Configuration, interfaces, again interfaces, select the interface, and finally click on enable. Right now you see here the status is, you click on and click on done. Fine. Okay, now you can go to the home page. It's up. Come back to configuration.
CDBA packets.
We want to see some things like it's getting packet or not, receiving packet or not. Simple way. For this, go to policies. Okay, for testing purpose, what you can do is go to
configuration.
go to configuration, go to
Policies.
under policies, go to
ISP policies.
IPS.
IPS policies.
Basically under IPS policies we do the linking part. Okay, now how do we link? Just understand this. Now basically this is the interface G00 of the sensor. Okay, now once this interface receives a packet, okay, inside you have a database. The default database present on the device is SIG0. That's the name of the database. Signature database, SIG0 database. Now as you know, there are multiple interfaces here. we have G00, we have G01, and so on. Point here is, how does the sensor know that any traffic received on G00 should be checked in this database? See, it's possible you can have SIG1. You need some mechanism in the device, or you need some configuration in the device, okay, which tells that, okay, anything received on 00, check it in signature database 0. Anything received on 01, check it in signature database 01, and so on. This we do using something known as
virtual sensor.
by default virtual sensor 0 is available on the device. So what we do is we take help of virtual sensor 0 and we say anything received on 00, check it against database. In fact, you can do this also. Anything received on 01, check it against, or you can do is this, anything received on, okay, or you can have altogether a different, you can do something like this. You can have a custom virtual sensor, and you can say anything received on this, check it against.
But why do we create different signature databases?
Okay, good question. Now we have signature database 0 that has a default signature sets. Okay, now I make some changes in this signature. Same signature I don't want for the another company. How to do this? If I enable this, it won't work for me. If I enable it, it will work for me, not work for him. No, if I enable it, it will work for me and work for him also. But I don't want it to work for him. Similarly, some settings are there for only for what I want, only for him. Will also work for me also, for my network also. I don't want this. I want separate policies for each company on each interface. So I need separate databases. Okay. Basically what you are going to do is you have only one database. All you are going to do is you are going to virtualize this database. You're going to make copies of this database, and then whatever settings you make in this database are independent of the other one. Maybe you enable 3 signatures here, those same 3 signatures are disabled in this one. So completely independent, you can do it. Okay, so basically as per this topology, okay, I can have a signature database here. I can have, let's say, signature database 1, which is for this branch, where I can configure different set of signatures. I can have signature database 0 and signature database 0, both for my company. Now these two are for my company. This is for a third party. So for him I have to configure completely different set of signatures. His policies are different from my policies. So my database, here I will configure signature for my company. Here I will configure signature for his branch. But everything is done within the same device. Okay, that's the difference. Now so this is where you have to come, and you need to click on edit. Already you have a virtual sensor, you can read it here. Do you read this? Already you have virtual sensor, you have interfaces, you have database also. All you have to do is virtual sensor 0. So we'll say interface G00 is linked. Anything received on G00 with the help of virtual sensor 0, check it against signature database 0. Understand this? Okay. So that's what we do. We select this, click on assign, let the database be 0 only, and click on OK. Click on if everything is working fine. At this moment, if we ping from R5 to R2, the ping goes to R2, but the copy of the packet goes to sensor, and sensor should reflect it. Okay, for to get this, what we need is configure a signature, for which you need to go to the database which you find here. Wait a minute, let me delete this one. So you were here, and what do you need to do? IPS policies, assign G00 to
With
done. Next, what we need to do is configure a signature, which you do it here. Controls. Policies. Under this, you need to go to signature. Under this, you go to. Under this, you go to. Okay, now what you do is SIG definition, SIG0, go to all signatures.
Check this, we lost this one.
Reconnect, no?
Go to team view and connect again.
I can click on connect. Now Now these are the signatures. The device at present has total of, out of which are already enabled. Okay, the enabled signature you would see with this. All these are enabled. All these signatures are enabled. Okay, what you see here is the signature ID. Okay, what you see here is the signature name. Okay, and these are the different engines.
Protocol.
For different type of packet, we have different engines to analyze it. Okay, now basically you further have controls over here. You can filter the signatures based on the ID, if you know, based on name, based on whether they are enabled or not, based on their severity level. Okay, their fidelity rating. We will get into all these technical terms later. Their base RR risk rating, and their actions, and whether they are tuned or not, and what type of engine they are using. So let's say we do it based on name. I want to see all signatures which are for ICMP. So I can say ICMP, and now I get to see all the signatures with keyword ICMP in it. I want to see ICMP echo pack signature for echo request packets. Okay, you get echo reply, echo request also. Let's tune this one because this is by default disabled. So we'll tune this, we'll say enable and apply. Okay, by default you see the action here is what? Alert, which means whenever any ICMP echo packet is seen, do what? Generate alert. So from R5 we are going to ping to R2, copy will reach IPS, IPS will analyze it, signature is enabled, packet is ICMP echo, signature is ICMP echo, matches, action is to generate, we get to see the alert. So let's do this. So where do we see the alert? Under, so go to monitoring and click on view. So right now there is nothing. Okay, but once we go to router and we do a ping to, and when we come back and we are getting this, and your promiscuous mode deployment is successful, right? If you click on details here, you will get to see the details. Okay, you can read the details here. The host name is, okay, the signature was, okay, it was with the help of virtual sensor 0. The attacker IP address here is router 5, and the target we try to ping. Okay, this was received through interface, and the protocol was, so which means what?
Someone tries to ping on
Your
the
your RSPAN is working fine. This proves your RSPAN config is proper because you are receiving the packet successfully. Okay, this proves that your binding is proper, your interface is in functional state, you have properly binded it to the database using the virtual sensor. Okay, now you can go ahead, you can go on configuring different signatures and it will work, because ultimately it's getting what? The packets.
Just one time you will give alert.
Yeah.
No, you think why?
On what basis we select and enable signatures?
Hmm?
On what basis we enable signature? Because there are lots of signatures. First we have to identify what are the services running in our internal network.
Yeah,
And
that's,
for each service, what are the available signature? So that
you can create custom as well.
how can we develop it? Suppose we want to enable 560
Hmm.
कैसे करेंगे ये चीज़? इतने सारे signatures तो याद नहीं रहेंगे.
नहीं है,
कौन
but
से signature किस अटैक के लिए वो भी नहीं पता चलेगा.
no, that you can find out. You can filter it out, no?
By name you can filter it out.
Like,
हाँ, लेकिन ऐसी बहुत सारी services होती हैं जिसको हम
like these are for ARP.
Or there you have to know.
Like if you want that in ARP, that's for ARP spoofing.
So
If you understand in ARP, the source is broadcasted, broadcast address, or so you can do this. Reply is broadcast, means if someone is trying to do ARP spoofing by replying, sending ARP packet, spoofed packet to everyone, this can detect it. But make sure you get the copy of the packet.
But this can be done only for the networking terminologies we can know, and for the other services, this is SMB. SMB is Samba service.
Huh?
So whether it is working on our
Which one? S.
SMB, no, the above R SMB remote.
Huh.
It is a Samba service.
So that, see, that you will already know, no? And if you are in the network, the configuring, you will already know what service you are running. Definitely. If you are not aware, what you will configure, you will have all the information, what services, what things you are running. And apart from that, you need to keep monitoring it, and based on alerts also you need to. It's not one day work. You need to continuously keep tuning it.
So the new software is installed.
If you get alert for some new packets, you need to keep doing it. So for that you can create and do it.
So there's a dedicated one person only for
Yeah, you need one.
IPS.
You need one. Okay.
IPS monitoring.
And if you are aware of, then these are the different categories what you can have it. Like for instant messaging.
AOL is outdated.
Okay. Like for DOS attacks,
DDoS.
ICMP Smurf attack. What we have done using what?
Fragile attack or Smurf.
The Fragile attack or Smurf attack.
Same.
What we did.
Half TCP.
The DOS attack, like ICMP flood. We did it for ICMP flood, right? By doing control plane policing, marking it.
Read limit.
Okay.
Control plane policing. Read limit.
So those we can do it from here also. UDP host flood.
No, this signature is enabled. If such kind of packet is received on that particular interface, they generate an alert for you. Because right now the condition is alert. If you want to deny, then first put your IPS in line mode.
This is for TCP sync flood,
flood DOS. Okay.
right? IP options.
Bad option list.
Okay.
Okay.
Then
Thanks.
these are for the attacks.
Mercy malware. Two digital malware. First
Okay.
we need to know what are these things. Metasploit.
For adware, spyware. This for peer-to-peer.
Reconnaissance.
These attacks will be someone from the host, right?
These are for BitTorrent. Okay. Some of them you know. This for reconnaissance.
Nmap. You can disable all Nmap action.
Mm.
Web server.
Okay.
For example,
For web server related. Like for Apache. Okay.
Use for
These are using the code what we have in HTML now.
these are signatures. Suppose someone tries from the outside, tries to attack on your Apache server, then they can get it.
Basically for this, if you will notice here, the engine is completely different. For the web sim, all signatures are processed by service HTTP engine here. So engines are different. Now service HTTP engine is dedicated for HTTP packets. It can understand HTTP packets very well, completely. For ICMP we have ICMP. For something which is on TCP based, you can have string TCP and so on. Fine. Now who is this one? Done. Another one. What's the time? 11:30.
11:27. The same configuration for inline. Different configuration.
Now let's do it for inline interface pair deployment. Okay. Now as you guys see that we don't have any communication between R4 to
ASC.
firewall until and unless we don't configure this. Okay, so what we need to do basically is very first identify the interface what we are using. We are using
E03, G00.
no.
So one doubt.
Yeah.
The attacker is from outside. He'll be having a private IP, right?
No, not necessary.
No, you already blocked the private IP address. Infrastructure is.
Wait.
0102. Huh.
That doubt I had. Because the attacker is outside, he'll be having private IP.
Not
Private
necessary.
IP is
So private IP we block it using an infrastructure receiver.
You can do it for internal segment also, no problem. It's
suppose
nothing.
an internal segment, someone tries to attack-
Internally also someone is doing it, you can detect it, no problem.
I try to access your files from your system.
Internally also you can do it. Not just external, you can do it for it. Now here we are using G01 and G02. So let's go and put IPS 01 in and 02 in. So let's do this very first. Now where is 01 and 02? 01 is in VLAN 5. Now where is IPS? IPS 01 is on switch 5. Okay. So on switch 5, interface F1/0/2, switch port, host, switch port, access, VLAN what? And another one is
Switch 4.
02, which is on switch 4. Switch 4 port 50. On switch 4 port
F0 slash
and switch port host, switch port access VLAN.
55.
Done. Okay.
Is it M1?
Yeah. Switch 4. Switch 5. Oh no. What was switch 4 port 2? What was switch 4 port 2?
55.
Wait. Switch 4 port 2. Switch 4.
Otherwise the firewall will not
Now what we have to do is switch 4 port 15 and switch 5 port 2. Done. Okay. Now if I was the router there R4, I guess. Yeah. Okay. Let me go to R4 and we try to ping firewall. It shouldn't ping as of now. Say ping 192.168.40. You link, it should start pinging. If it is pinging, means your config is.
No, first thing is the interface, the 01 and the 02 is not enabled.
Yeah,
And
no, even
IPS
if you enable it. Even if you enable it, you need to pair it. That's the important. So, how do we configure this? We go to sensor, configuration, then go to
interface,
exactly. Then go to again interface and enable the interfaces what we need. We need 01 and so 01 enable, 02 apply.
Now it should work. Because both are in
You need to
different
pair them. So for pairing purpose, you need to go right below this control, interface pair. Okay, click on add, give some name, maybe DMZ interface pair.
and select two interface.
Select two interfaces.
1 and 2.
Use control key on the keyboard and select two interfaces 01 and
Okay.
okay 40.
40 and 0. Interface pair.
Say okay. Say
Apply.
okay. Now if it is perfect,
Perfect. Let's start.
they should ping. Do we have those VLANs? Now, so on switch 5, right? Sorry. Switch 4 and switch 5. Disconnected on port 5. 01. Okay. Switch.
There are VLANs.
Yeah, that's what I need to check. Show. Yeah, we have it. It should be on server switch, that's more important. VLAN 5,
55.
VLAN 55, we have it. Fine. If this is working,
We get the packet.
this is the confirmation.
Once you get the packet, you can-
Okay.
What's
Uh,
your sensor?
If you want to check, all you need to do is go to policies, IPS policies, apply this pair to the sensor. So again click on edit, say anything received on this interface pair, check it against database 0, say OK and apply. That's it. The database, the signature for ICMP is already configured, so whenever it sees ICMP echo packet, it should give you alert. Okay, only thing, the interface it should show different. So let's do a ping again. This is working. For this you should get some, you get another alert here, but this alert is on that DMZ pair interface, not on G00 interface.
Interface G02.
Read this. It's coming from
R4
to
is
firewall through
G02.
02 is a part of that interface.
Interface VLAN pair.
Interface pair, not
Interface
VLAN. Done. This is interface pair deployment. Okay. Last, third segment which is not working here is which one?
Group.
This one. Now we have only one interface remaining of IPS and we have two VLANs. So what we need to do? Subdivide it. So first identify where is G03 of IPS is connected. This one. And then divide it into 2. So
Switch 4.
check the topology.
Switch 4 with F16.
Switch 4 port.
16.
As it is handling multiple VLAN traffic, what you need to do is
Trunk.
exactly. So switch 4 interface F016 F1
.1Q.
switch port trunk encapsulation .1Q switch port trunk switch port mode trunk switch port trunk allowed VLANs 2 and go to switch 4. Okay. Right now we go to R3 and if I say ping the firewall 192.168.30.10, this won't work.
Because the interface is down.
Okay,
First we need to
go to the device,
configuration.
same step. First go to interfaces, enable your interface 03, apply. Next thing, you have to form a VLAN pair, not interface pair, VLAN pair, for which you click on add. Which interface? Only one is available. 0 is for promiscuous, 0 1 and 2 are in interface pair, 03 only one available. Sub interface number, only one you can give, another one is already there. So I would say 22. VLAN 2 and okay, I'll say just a name. Okay,
The 3.0 will be already there.
yeah, you will get 2 now, 3.0 and 3.22. Okay, done. Apply. Fine. If you want to see the signature alert, you can go to policies, IPS policies, edit, and assign your. Do you see this? Select this as well. Assign. Okay. Now when you ping, it should work, and you should get. So
if you enable the signature,
go to R3. It's pinging.
refresh.
It should show on which interface? 0.
03. Which is 03. Okay.
From R3 to
Okay.
Firewall. VLAN 22. It was seen in VLAN. Done. Okay. It's very important. You get it? Simple, easy. Okay, but very important, very critical. There's another part behind this, that's configuration of the signatures or something else. That's different part. You get marked separately for that thing. Only for this, what I showed you till now, you get marked for this separately. Okay, and you get around around 15 to 18 or 17 marks for this, what we have done so far.
All the three
Where?
are in the same.
Only on the IPS part I'm saying. Only on the IPS, if you